This is the first lesson of an econ unit we're going to do. This will go well with what you've already learned in econ, but what we find year to year is that I tend to cover some other materials that you don't see in that econ class, and I tend to put more algebra focus onto it. It's a lot of Algebra 2 concepts that you're going to see come up in this section here. So the first thing we're doing is supply and demand. You do need to look through here. There's definitely a lot of keywords, key vocab, things like that, graphs, examples that you're going to want to do for the problems at the end. But what I intend to do with you is a little bit of supplement stuff to kind of go along with this to help you understand how it works. So in class, this is always how I start off. I usually let y'all kind of pick some item to buy, but I figured a cell phone would be a good one here. So let's say I have a phone that costs $1,000 if I buy it in a store. I have one right here with me. And let's just say I've got 50 people in the room. Let's say I do it in the cafeteria maybe, something like that. So I've got this phone that would cost you $1,000 if you went to a store and bought it. And I'm going to try to auction it off and see how much money I can make. And this is kind of how eBay works or any other auction. This is what they do. So I've set up kind of a chart here first. I've got a lot of prices. They're in increments of $100, starting at $400. And I'm just going to ask how many people would pay this price. And of course, I'm making this up. This is kind of typically how it would go. I'll start for $400. Not everybody's going to raise their hand. Not everyone needs a phone. Some people don't need a phone, but they see that they can get a really good deal, and maybe they think they can resell it for more. So a lot of people are going to be interested at that price because it's so low, but not everybody's going to be interested. So I'm going to say maybe 48 people say, hey, I want that. I'll pay $400 for it. All right, now I say, all right, well, how many of you would pay $500? Well, a lot of hands are going to go down because maybe at that price, that's getting to be more, not as many people are as interested. So let's say maybe 41 people say, yeah, I'll give you $500. All right, so let's say I just keep raising. Let's say $600. All right, so more hands are going to go down. Maybe 33 people still, what we say in the market. Okay, the price goes up to 700. Say, how many people still wait? Well, maybe there's a big drop now. Maybe it goes down to 21 or something. All right, raise the price to 800. Say, how many people are still interested? All right, and it's going to keep dropping. Let's say 14 people. Or go to 900. I'm getting really close to what it really costs in the store. Plus, I mean, this is something I'm holding up. You don't know the quality of it. I mean, there's a lot of factors you can think about why you might not want to buy it from me. But let's say maybe you just don't have the cash. Maybe you just can't buy it. You just can't physically do it. So let's say that 9 people are still interested. Let's say I get up to $1,000. Let's say there's not many people at that point because maybe there's a couple people that are still willing, but at that point you could probably just go to the store and buy it. There's really no point in risking buying it from me or for whatever reason. So that's kind of how a demand curve would play out. If the price is low, a lot of people want it. As the price goes up, fewer and fewer people are willing to pay that price. And then we put it over here. So $400, so I'm trying to keep this kind of spaced evenly. 400 is going to be about right in there. And a lot of people are still in the market. By $500 down to 41, $600, we're at 7, 8, let's put all those in there. $600, we're at 33. Pretty linear so far. And in real life, these are not going to be so linear. This is just kind of because I'm picking numbers, but we'll look at some examples in a minute. So 800 was 14, 900 was 9, 3 people down here. So it's kind of not a perfect, it's never going to be a perfectly straight line. But for the ones we're going to do, they are going to be lines of best fit. So you'll put kind of a line of best fit through it, and that'll be your what we call demand curve. And I'm going to show you at the end mathematically how you can create that. But demand curves are always going down from left to right. And here's some examples. Again, in real life, they're going to be actually curved. That's why they're called a demand curve. Very rarely will you see lines. But to keep the algebra simple, we're just going to deal with lines. Typically, to do real stuff like this, you're using calculus. So, but we can certainly do economics with algebra, just simplify it. That's what we're going to do. A couple key things before I move on. On the graph, I've labeled the y-axis quantity, the x-axis is price. Quantity is simply how many people are willing to pay this amount. And of course, price is the dollar amount. All right, we looked at demand, so let's take a look at supply on this one. So I'm selling bags of chips in a store. It costs me $1 to buy from Lay's or Doritos or wherever the truck is. The wholesale price is $1. Okay, so I'm going to look at 50 stores and see what they are willing to sell these chips for. All right, so just one more time. If I'm a store, I bought this bag of chips for $1 off of the supply truck, and now I'm trying to set my price to sell to you as a customer. So let's think of how this might play out. So how would you be willing, let's say there's 50 stores, and this is kind of how the survey played out. Kind of similar to how I asked y'all, maybe I'm asking a bunch of stores. So how many would sell it for $1? Well, since it costs $1 to buy and you sell it back for $1 to a customer, you don't make any money. So maybe there's 1 or 2 stores that might try that. And maybe they've got some other motivation in mind. Maybe they run a special where they sell the chips at a regular price, but then they raise the price of their Pepsi's up a little bit to try to get you to buy those or something. So that's probably some kind of scheme going on if they sell it at the actual price they paid. $1.25. Well, that's not very much profit. I'm making a quarter off each bag I sell. So not a lot of stores are going to be willing to do that, maybe a few. And then this is where you start to think about probably your convenience stores. They're not going to sell things this cheap. Only your big stores are going to do that, like Walmart. Even Food Lion and Kroger tend to be a little higher. So there's not very many stores that are going to sell things at a low price. But this is why, because they won't turn much profit if they sell it too cheap. So let's raise it up. Let's say $1.50. Let's say maybe 8 stores are okay selling it at $1.50. Still pretty cheap, not making much profit. $1.75. Let's say a lot of stores are starting to kind of be okay with that price. And if I raise the price to $2, well, at that point I'm doubling my money. I paid $1 for these chips. I'm making $1 profit. That's pretty good for me as a store. So let's say a lot of stores are willing to do that out of 50. $2.25. Let's say a few more stores really want to make that $1.25 profit each. And then by $2.50, let's say that every store we surveyed is willing to sell it for $2.50. Okay. Now keep in mind that Walmart was willing to sell it for $2 or less. So think of it that way. It's, would you sell it for $2 or less? This is kind of cumulative. All right, so $1, we only had 1 store willing to sell for $1. $1.25, let's put some tick marks in there. $1, right, 3 people, 3 stores. $1.50 was up to 8. $1.75 is up to 23. Kind of rose pretty steep right there. $2 up to 40. And then it kind of leveled out. $2.25 and $2.50, at 44 and 50. So if we're going to put a line through this, it's a pretty steep line. It looks probably something like that. That's a supply curve. And again, curve, because if you really tried to make this work, it would be more of a curved kind of line. We won't get into what those might be called. Let's just go with a straight line here, trying to align the best fit. So supply curves, they always go up from left to right, because if it's really cheap, there's only a few stores that are willing to let something go really cheap because they're not making much profit. But all stores are willing to sell things at a high price because you make more profit that way. That's a game too. You can probably imagine that the convenience store, you don't have the volume of people coming through like Walmart has. So Walmart can get by selling things super cheap because they have thousands of people coming through every day. Whereas a convenience store might only have a few hundred, or maybe even less than 100 people. So they really need to make a profit off the people they do sell to. As far as your graph is going, make sure you keep a track of the same 2 axes. Price is on the X, and quantity is on the Y-axis. And that's important that those are both going to be the same way. And in the next example, we're going to put them together so you see how it plays out together. So here are 3 key words that are going to come up on the lesson: equilibrium, shortage, and surplus. Now, equilibrium is where the market balances out. You look at what people are willing to pay, what stores are willing to sell it for, and you just kind of see where it evens out. And that's the place where they cross out here. That's your equilibrium. And you find that by just letting time go on. I mean, this stuff's not exact science. Prices go up and down, they change. As more people buy something that's new, there's less demand for it, so things are always shifting. That's why calculus comes into play a lot of times with economics. But just to keep it simple, where the 2 lines cross, that is your equilibrium point. And ideally, that's where an item is going to sell for. So let's just say this is back to that cell phone. And it looks like probably around 700, 750 is what this cell phone will eventually end up selling for. Let's say it's one of the Droid phones. That there's hundreds of those out there. So it's not like the top high-end Droid phone. It's just another one of the hundreds that are available. So this one is going to go for about 700 because that's where the demand and supply are meeting up. All right. Well, let's talk about what happens if the price gets set too low or too high. So let's say that a store sets the price at 500. All right. So let's kind of look at what's happening on the supply and the demand end. Well, at the demand part, there's about 35 people, and we can make this in thousands or whatever. We can say there's 35,000 people demanding it. But that's about how many, there's how many people want this phone at that price. Definitely higher than at the equilibrium price. Because if the price is cheaper, more people are willing to pay it. But less stores at this price are willing to sell it that cheap because they think they can make more money off of it. A few stores are willing to let it go cheap, but most stores want to make more money. So at this point, you end up with what you call a shortage. And you got a shortage here because you simply have more people that want it than how many phones are actually available at that price. So if that was the going price, let's say this phone came out at $500. Well, that means you've got a lot of people that are willing to pay it, but not that many stores willing to sell it at that price. And that's why you would see a shortage. You wouldn't be able to find this phone. It would be really difficult to find. And the price is going to go up. I mean, you think about common sense what you would do. Let's suppose that you didn't really want this phone, but you were able to get a hold of it for $500. And you see that people can't find it. What are you going to do? You're going to sell it for a higher price because you can get it. So that's why the price is going to move toward that equilibrium. So let's look at what happens if we're on the other side of this. Let's say the price is set at $1,000 coming out. Okay. Well, as far as demand, there's about 20 people that want this phone at that price. There's a lot of stores that are willing to sell it. Pretty much every store is willing to sell it for $1,000. So they're all buying it up because they're thinking, all right, yeah, we'll put a $1,000 price tag on this thing. We'll let it go for that price. Well, this is when you see a surplus. Because you've got all these stores that have it, you have very few people willing to buy it. So they're just sitting on the shelves. No one's buying it. And you think about what a store would do, what you would do if you've got an item no one's buying it. You're going to lower the price. So if the price is too high, you get a surplus. The price is going to move back down here to this equilibrium. And that's how it plays out. And that's why things change in price at first. A lot of things come out really expensive and they don't sell so great, so the price comes down. Sometimes things come out kind of cheap and they sell out really fast and companies raise the price because they know they can get it. So as you're looking through the notes, of course, read all the details here. Here's some examples of equilibrium, surplus, and shortage. There's definitely some math problems. You're going to have some math problems to do on the homework, but these parts, I think they're pretty straightforward. You can read through them. You can always ask if you have any questions. I do want to get down to example 4 and talk to you about how we find this demand curve. We can do the same thing for supply, but you're definitely going to need to do it for demand. Ideally, the goal of this unit is for you to eventually be able to set the selling price for an item in a store that you are running as a project. So that's where we're going. You've got to, these are all the key things that you need to be able to do to eventually be able to set that perfect selling price. Because that's what it's all about. That thing we just did a second ago, finding the equilibrium, that's tough to do in real life. So it's all about trying to find that equilibrium and selling price so you make the most profit possible. On 4, they don't really tell us what we're selling here, but they give us the different wholesale prices and how many retailers would purchase this. So this is how many people would be willing to buy the item if it costs these different prices. And you can kind of see as the price goes up, the number of people willing to buy goes down. They do give us an equation here, so we need to talk about how we can come up with that. Easiest way is in your calculator. Go to Stat, and then go to Edit. Now, if you've already got something in here, go up and hit Clear, and come back down. If you accidentally hit Delete, I know Delete kind of makes sense, but it's going to mess things up. So let me show you what happens if you hit Delete. Say you went up here and you couldn't remember and you hit Delete. And the list actually goes away. Now, you need L1 and L2. If you don't have L1, L2, you're in trouble. If that happens to you, go back to Stat, go down to number 5, which says Setup Editor. and enter. And once it says done, if you go back, just repeat what we just did, stat, edit, it should be back. And this time, make sure you hit clear. And what I'm going to do is go through and type in all these numbers out of the book, and when I come back, I'll have it completed and I'll show you how to finish up getting that equation. A couple things to notice once you get this in here. I don't have to put 16.00, 16 is good enough, 17 is good enough. I can put 15.5 instead of 1550, that's fine too. Double check all of your numbers, all your prices, all the quantities, make sure they match up perfectly with your chart. If they don't, the equation's going to be wrong. Once you've got those in there, you did all this in Algebra 2, so it's kind of a review here. You go to Stat. Now you're going to go over to Calc. You're going to pick number 4, which is line of regression. And there's a lot of options here that you can change. We're not going to change any of them. We're just going to go straight down to Calculate. And there we go. So you can ignore the R and the R squared. This was for something I was doing in pre-calc. But you should have A and B. You very well may not have these two things on here. So it gives you kind of a key. It says A goes right here, that's your slope. B goes right here, that's your y-intercept from Algebra 1. And here you go, negative 1756 goes in front of X, 30,238 goes in for B. And we'll just double check, make sure that's matching up. And yeah, it looks like it's matching up exactly with what the book. It might not be down to the decimal point, but it's pretty close. It's going to be good enough. So that's how they got that equation. One more thing to think about here. This was X and Y, which is the way you typically graph something in algebra, X-axis, Y-axis. You don't have an X and Y-axis. You have a quantity and price axis. These axes are super important with econ. And as we go into different types of graphs, we're going to label the axes different ways because it all depends on what we're trying to explain, what information we're trying to convey. So for now, it's quantity this way on the y-axis, price on the x-axis. So where you have an x here, that should be a p. Where you have a y here, that should be a q. And that's what you're going to see in the example. You're going to see that they have q instead of y equals. Instead of x for the slope here, they're going to have p. When you get to the assignment, there's going to be a lot of things that were in the notes that I didn't necessarily talk about here. Just again, make sure you read through everything. Refer back to some of the other examples if you get stuck. But here are all the problems you need to try. And if you have any issues, just don't be afraid to ask me. We can do a meet, or we can talk about it some other way. I can make a video for you. I can come up with something. But just make sure you're okay with how to do all of these, because eventually they're going to show up on a quiz, a test, and you're going to have to show that you can do these on a project.